Alrighty, in section 2.8 and 2.9, we were talking about manipulating different equations so that they could be more useful for us. So the start thinking part, we were talking about in science class how there is a formula that relates distance and rate and time, and students remembered the fact that that formula was distance equals rate times time, and then we were supposed to use that to be able to fill out the table that you can see to the right here. Um, as you can see, the formula D equals RT is perfect for the first three rows because you have your R and your T and you're solving for D, so everything is just set up. It's just 3 times 5 is 15, 4 times 2 is 8, and 7 times 1 is 7. Now on the next three rows, instead of solving for D, we were solving for R. And when you're trying to solve for R and you put the D and the T into the formula, D equals RT, you end up having to solve an equation. I don't have the work on there right in the actual piece of paper that you're looking at, but basically for that first one, you would have 3 equals R times 8, and then you would have to do a one-step equation. Of course, solving a one-step equation is not that big of a deal, but it's still not the most efficient thing that we can do. So what we discussed was the fact that you can get your original formula or equation, D equals RT, and solve it for R or solve it for T. And those three columns where you're solving for R, it would be handy if instead of it being in D equals form, it was in R equals form. So you can get R equals D over T. And then everything is nicely set up. You don't have to solve any equations. It's just what you're going to be able to put in your calculator, or just it gives you the answer. You have D, which is 3, T, which is 8, so it's going to be 3 over 8. D, which is 7, T, which is 6, and you're going to have 7 over 6. But my point here, the main thing that we're getting out of this start thinking part, is just the fact that sometimes the original equation that you get is not going to help you be the most efficient that you possibly can if it's not solved for the correct variable. Now, of course, in this one, it's not that big of a deal because you would only be solving a one-step equation. But if you had something much more complex, it just saves so much time if you're trying to solve for a certain variable if the equation is already in that variable equals form. So, um, and we also talked about sometimes, let's say you were only going over and finding one of the rates. You might just choose, instead of getting it into R equals form, you would just leave it in D equals form and then just solve the equation. Whereas if you were trying to solve 3 or 4 or 5 equations for R, it might be worth your time to go ahead and solve for R. As you guys can see in that first case, if we're solving for R, you just divide T away, and that's how you got D over T. If you're trying to get T by itself, you divide by R, and that's how you got D over R. This first example here was just asking with the table, which one of these equations actually models the table. And when you look at it, B equaling 3A is not correct. That is not going to model the table. But we did find that both B and D were both equations that represented the information in the table. Now, why would you have the equation in answer B? That would be if you're solving for B. And why would you want the equation that they have for D? That is if you're solving for A. Once again, it's the same. There are equivalent equations and formulas, but since one of them is in B equals and one of them is in AA equals form, it just makes it so that you can solve a little bit more efficiently. We looked at this problem right here. Usually the book is asking you guys to do problems without going over and writing an equation first. And their point is that take a look in problem number 1, example 1. It says tank A is initially containing 124 liters of water. It's then being filled at a rate of 9 liters per minute. And they want to know how much is in there after 4 minutes, 80 seconds, and after M minutes. Now, if you just write out the problem, it'd be 124 plus 9 times 4, or 124 plus 9 times 80 over 60, because 80 over 60 represents how many minutes are actually passing. The reason why the book likes you to do this is that you get comfortable working with numbers, and then when you have a format that you know is correct, then you could switch out the number of minutes, which we've been using actual numbers for an m, and that's how you get your equation of 124 plus 9m. Now, once you get better and better and get more comfortable in algebra, a lot of times you're going to jump straight to the equation. So I jumped straight to the equation of W equals 124 plus 9x. And then once I had that, it made it very easy for me to solve for the amount of water that was going to be in there. And since it is in W equals format, then I know that it's going to be very easy to solve for W. You'll just substitute in a 4 or an 80 over 60, and it will spit out your answer. You can use your calculator for that. Now on part number 2, instead of us solving for the amount of water that's in there, you're given the amount of water and you're trying to figure out how many minutes have passed. Now you could just substitute in 151 for the amount of water and then solve a two-step equation, but if you're doing that multiple times, it's not super efficient. So it's actually way easier, since you're going to be doing this multiple times, to just get the equation in a different format. So I got the equation, as you can see in D. The equation is x equals p minus 124 all over 9. And what that means is you're finding out how many gallons more than the original 124 there have been, and you know every 9 of those gallons is a minute. So since it is in that format, it's very easy to solve for the number of minutes. We had another problem here. This one, once again, had to do with a situation where you have a certain maximum amount. It says that a ship can carry 21,600 tons, and a car weighs 3.6 tons, and a truck weighs 7.5 tons. They were hoping that you would go through the process of just cranking through it without writing an equation. Nope, actually this time if I look at it again, number 1 does ask for the equation, and we came up with the equation of 21,600 equals 3.6c plus 7.5t. So that's the equation we're working with. Now, the first part here, which is part 2, is they are going over and asking how many cars you're going to have if this is how many trucks there are. Now, the equation that we have in part 1 is not in C equals format or T equals format, but since we know that we're going to be solving for the number of cars, it made sense for us to get the equation in C equals format. And when you look at this, the way that you get it into C equals format is you get rid of that 7.5t by subtracting it away. So you have 21,600 minus 7.5t, and then you could divide by 3.6. And you can see the equation that I have here. And once you have it in that format, it's very easy to substitute in the 480, the 1500, the 2736, to substitute all those in, and then just pop it in your calculator, and it will spit out the answer. Now, this last problem that we had here was similar to that problem. This problem was saying that you had $1.9628 million in the budget for resurfacing a road. They tell you how much it's going to cost for each mile when you're talking about just the concrete and everything. And then they tell you how much it costs for a salary for one of the workers. And we come up with our equation. Our equation is, it says write an equation that represents the relationship between the miles of 2-lane road the department could resurface M and the number of new workers it can hire P if it spends the entire budget. So it looks like I did not write that equation down, but basically the total 1.9628 million is going to equal the 84,000 M, that accounts for the cost for the actual roads, plus 36,000 P. And that is talking about 36,000 times the number of people that they're hiring. And what I did here is if you were solving for P, it was just practicing getting the P by itself. And then the next one was solving for M, and we got the M by itself. And that's just a method of basically solving the equation for a different variable. So that is what the lesson was about. The lesson was basically about the fact that it becomes more efficient when you are able to get an equation into a certain form. In this case, either P equals form or M equals form. Really a generic formula that you probably would have come up with was total 1,962,800 equals 84,000 times M, the number of miles that you pave, and then 36,000 P. But that formula does not solve for P or for M. It's easier and more handy to get it in P equals or M equals format. Now, when we go over the homework here, homework for 2.8 and 2.9, it's the same concept here. They're talking about a situation where a car has 16 gallons for a fuel tank and they get 30 miles per gallon. So you have the understanding that every gallon that goes away was 30 miles they drove. And they have, in part 1, you can figure out how many miles they drove if they had 15 gallons left, 10 gallons, or 2.5 gallons. If they have 15 gallons left, 1 gallon went away, and that 1 gallon was 30 miles. And part B, if 6 gallons went away and each gallon was 30 miles, it's 180 miles. And the other one would be 13.5 gallons went away. And if each one of those gallons was 30 miles, you end up with 405. Now, I went straight to an equation because I like equations. I want to remind you guys there are many equivalent equations. So I put L equals 16 minus M over 30. That means the amount of gas left is equal to 16 original gallons minus the mileage over 30, because every 30 miles was 1 gallon. You could also have the equation of M equals L minus 16 times negative 30. The number of miles that you drove is basically the difference between the 16 that you had and how much you have now, and then 30 miles. The reason why I did negative 30 was just because I was going to end up with a negative number when I did L minus 16. The way that you can make it so you do not end up with that a negative and having to have a negative 30, as you can see in part 2, that's the equation you could have had, D equals 16 minus X times 30. On number 3, how many gallons are left? Once again, could you just go over and substitute 90 miles in and solve the equation, even though it's not in the correct form? Yes, but it's also kind of handy. We can just change up our formula so that it's in a different form. In this case, I'm calling it L equals the amount of gas left, and I was able to get it into that format so that I can do this super efficiently. Number 4 was just another, that was the equation I already came up with, 16 minus D over 30. The amount of miles you drove divided by 30 tells you how many gallons that you used, and then you would subtract that away from 16. Number 2, they're just trying to get this into a different form. If you're solving for W, then you can just divide away the L so that W is by itself, and you get the A over L, or A over 5, depending on if you're saying the length is 5, or just in general, whatever the length is. Number 3, the equation that I would have come up with originally, because they say it's $2.75 for a student ticket and $5.25 for an adult, and they made $281.25. I would have said 2.75 2.75s plus 5.25a equals the 281.25. That would be the generic equation I would have had. And then I would have tried to figure out if there's a way to manipulate that equation to end up with what we have here in A, B, C, D, or E. And it turns out that both A and B can get that original equation, which I told you was 2.75s plus 5.25a equals 281.25, and you can manipulate it to get it into A equals format or some other format. On number 4, this is saying here is the equation for the volume of a cylinder, and they want to know what would be a good formula if you just repeatedly, or if you're trying to solve for the height. Well, obviously A and D are out because they are not in H equals, which is height equals format. And then B was out because the way that you get rid of that pi r squared is not by subtracting it away, but by dividing it away. So C was your answer. On number 5, I actually messed up on this one. I circled B because when you substitute a 0 into B, it does spit out a 30. So I figured that was the answer. But I sillily did not go over and substitute in the 5 to see if I got 27.5, or the 10 to see if I got 20, or the 15 to see if I got 7.5. So once I actually did that, I realized that D was the only correct answer. D will work for 0, 5, 10, and 15. It will always give out the correct volume. Now on number 6 here, this is review over something that we've already done. They say that a small table can hold 6 people, a big table can hold 10 people, and we have 150 people. So the equation would be 6s plus 10L equals 150. That's what I did. But then it says basically what is a solution to this. I did the easy way of just saying all large tables, 15 large tables, no small tables. Then in part 2, they say, no, I don't want S's and L's, which is what I originally chose. They wanted X's and Y's. The next part says, what does 20,5 represent? That's 20 small tables and 5 large. Is 20,5 a solution? Well, just substitute it in and see if it works. And since it does not work, the answer is no. And then lastly, problem number 7 says, are these equivalent equations? They will be equivalent if all you did was distribute, combine, add something to both sides, subtract something from both sides, multiply by something on both sides, or divide by something on both sides. And when I look at this, I can see that it just went from 2x to 5x, which was add 3x. And on the other side, they also, they also added 3x. And since they just added the same thing on both sides, they must be equivalent. There you go. That's the lesson, and that was the homework. Thanks for watching.